All right, in 5.2a, we're going to continue on with right triangle trigonometry, and we're just going to revisit our right triangle and the angle theta that we're going to mark right there. Now, relative to angle theta, you have your opposite side, your adjacent side, and your hypotenuse. And then we have all these trig ratios that we can create. Sine is the opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. And then the reciprocal ratios, cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Secant's the reciprocal of cosine, so it's hypotenuse over adjacent. And then lastly, cotangent's the reciprocal of adjacent over opposite. All right, so that being said, I just want to make you think for a second. If this is angle theta, then what is this angle right here? Well, it's whatever 90 minus theta is, right? That's this angle right here. We know that because all three angles have to add up to 180, and this angle right here is already 90. So they're both acute angles. That's all I wanted to bring up to you because you will see this notation in some of the problems. All right, I just want you to realize it's the opposite angle of theta. That's not the right angle, and you can easily figure that out. And you'll begin to see some patterns as we go on through this. But first, let's look at some examples. So look at your instructions. It says find all 6 trig ratios for each triangle. So look at number 1 here. They're telling us the hypotenuse is 13, and one leg is 5, and we need to find the other leg. So how could we find the other leg with right triangles? We're going to use good old Pythagorean theorem. Remember, a squared plus b squared equals c squared. Well, the hypotenuse is always your c. That 5 can be a or b, it doesn't matter. So I'm just going to make it a. A squared, 5 squared plus b squared equals 13 squared. So that's 25 plus b squared equals 169. If I subtract that, I get b squared equals 144. Now remember, when you take a square root, the absolute value of b will be plus or minus 12, but we are talking distance and length, so it can't be negative. So we know that b must be the positive version of 12. All right, so this side is a 12. Now that we know all 3 sides, we can fill out the ratios. So our sine relative to theta here, opposite is 5, hypotenuse is 13. Cosine is adjacent, 12 over 13. Tangent is opposite over adjacent. Once we have those, we just do the reciprocals for the cosecant, the secant, and the cotangent. Okay, not so bad. Let's try another way this could be asked. Look at number 2. This one tells me, doesn't give me side lengths per se, but it does tell me a ratio. The cosine of theta is 3 over 7. So I have to stop and think. Cosine is adjacent over hypotenuse. So that means my adjacent side is 3, my hypotenuse is 7. Now we're back to where we were in our previous question. So let's just do a little Pythagorean theorem stuff. So this would be 7 squared is equal to 3 squared plus the unknown squared, right? So 49 equals 9 plus b squared. That means that b squared will be 40. Take the square root. Absolute value of b is then plus or minus the square root of 40. Now let's break that down. 4 square roots of 10. So that'd be 2 square roots of 10. We know it has to be positive because it's a length. So b is going to be 2 square roots of 10. Now we have a radical. Not impossible. We can do this. All right. So let's come back to our ratios. The sine of theta is the opposite, 2 square roots of 10 over 7. Cosine would be the adjacent over 7. They gave us that, right? The tangent is opposite 2 square roots of 10 over adjacent. Now, to do cosecants, you're going to have to flip this over, right? So when we do this, we're going to have to do a little bit of rationalizing. So let me just do a little work right here. When I flip it over, remember when we rationalize, we just need to multiply by what's under the radical. All right, so this will become 7 square roots of 10 over 2 times 10, which is 20. That doesn't reduce. Secant is the reciprocal cosine, so it'd be 7 over 3. And then this one, if I flip it, So it'd be 3 square roots of 10 over 20. All right, so there's my 6 trig ratios. Let's try another one. Look at number 3. Cosecant. This one is cosecant. So what does cosecant mean? Well, it's a reciprocal of sine, so it's the hypotenuse over the opposite. So now I know my hypotenuse is 17, the opposite side is 4. So I'm going to do some Pythagorean theorem work. So 17 squared let's do minus 4 squared is going to be my missing side squared, right? So you can use your calculator. 289 minus 16, sorry. 289 minus 16 gives me 273, and that's b squared. So if I take the square root, that means the absolute value of b is going to be plus or minus the square root of 273, but it has to be positive, so it's just square root of 273. All right, that's gross, but we can do this. All right, don't let the big number scare you. Okay, so now the sine relative to theta, opposite is 4 over 17. We could have done that with cosecant, right? Cosine, square root of 273 over 17. The radical on top is fine. Tangent is opposite over adjacent, so that would be 4 over square root of 273. So if we rationalize that, you'll begin to see these patterns evolve, and you won't have to necessarily do all the work, okay? So there's my tangent right there. Okay, now cosecant, if I flip it, 17 over 4, that was given, right? On secant, when I flip this over, I'll have 17 over the square root of 273. When I multiply, I have 17 square roots of 273 over 273. I can't reduce that, so leave it as it is. It's okay. And then cotangent, I can flip this over, but then I'm going to have to rationalize again. So what the best thing is to do is go before we rationalized it right here when we initially did our tangent and flip it over from there, and that'll save you that step. So that would be square root of 273 over 4. All right, so this just involves Pythagorean theorem, rationalizing, and knowing your ratios. All right, now let's look at the next part here. Using a given angle, find the trig functions. Now we're going to be using our good old, we're going to use our unit circle to do this. So let's look at this. Got extras in here, don't I? So we're going to use our unit circle on this next section. It says find the exact values of sine of 45 degrees, cosine of 45 degrees, and the tangent of 45 degrees. All right, so where is 45 degrees? Well, hopefully you realize that 45 is pi over 4, and look at that. It's square root of 2 over 2, square root of 2 over 2. So what is the sine? Well, the sine, remember, is the y value, so it's the square root of 2 over 2. The cosine is the x value. It is square root of 2 over 2. And tangent is these two divided by each other, right? So it's square root of 2 over 2 divided by the square root of 2 over 2. Well, what happens when you do that? You just get a tangent of 1. Now, find the exact values of each reciprocals, okay? So what's the reciprocal of sine? Well, that's cosecant of 45 degrees. Well, that would require us to have to rationalize, right? So let's rationalize that. See what we get. 2 square roots of 2 over 2. That 2 will cancel out, and it's just the square root of 2 when you rationalize square root of 2 over 2. What happens when we do this with the secant of 45 degrees? Well, it's the same fraction, right? If we rationalize it, we will end up at the same place of square root of 2 over 2. And cotangent, it's basically 1, and when you flip reciprocal of 1, it's still a 1, right? So that's helpful. And notice I just got that from the unit circle. Okay, so we're going to again use the unit circle to find the exact values of the sine of 60, the cosine of 60, the sine of 30, and the cosine of 30. All right, now use our unit circle. Let's look at at 60 degrees first. So here's 60 degrees. Remember, sine is the y value, so the sine is the square root of 3 over 2. The cosine of 60 is the x value, so it's 1/2. Now if we switch gears and we go to 30 degrees, look at this. The sine is what, 1/2? And the cosine is the square root of 3 over 2. Now, why the heck did we do this? Well, because I want you to notice something here. The sine of 60 and the cosine of 30 are the same. Cosine of 60 and the sine of 30 are the same. We call those cofunctions. Okay, you end up with the same result because they are what we call cofunctions. Now, why does that work? Well, it goes back to what I was showing you before. Remember how we originally started here? If this is theta, then this angle is 90 minus theta. If theta is 60, 90 minus theta is 30. So because of that, they are cofunctions of each other. Now that's helpful anytime you realize that, oh, these angles are complements, right? They add up to 90. They're complements of each other, and they are the sine and the cosine. So it ends up being the same result. It can be a shortcut of sorts if you catch it. All right, you'll see some of that on your assignment, but don't let it trip you up too bad. All right, now let's move on to the next section. We're just going to keep up with our unit circle. So I'm going to erase my notations just for a second and move my unit circle around a bit. Okay, this next section, it's just more practice using our unit circle to find the exact values. All right, so let's remember tangent of pi over 4. So to find tangent of pi over 4, I'm going to take the x coordinate over the y coordinate, right? So where's pi over 4? Well, pi over 4 is 45 degrees right here. And we just did this, right? What is the tangent when x is square root of 2 over 2 and y is square root of 2 over 2? Well, it's dividing by the same number, so my tangent is just a 1. So this is practice of what we've done before. So I want you to pause the video. I want you to do these on your own and come back and check your work in just a moment. So for cosine of pi over 4, I got the square root of 2 over 2. For the tangent of pi over 3, I got the square root of 3. The sine of pi over 6 is the square root of 3 over 2. The tangent of pi over 6 is the square root of 3 over 3. And the cosine of pi over 3 is 1/2. Now, let me show you a shortcut that I just do mentally to help me not have to calculate tangent every single time, right? Well, the tangent of pi over 4 is just a 1, isn't it? The tangent at 30 degrees or pi over 6 is going to be square root of 3 over 3. And the one at 60 degrees is going to be the square root of 3. Now, how do I keep that straight? Well, I keep it straight because of this. 6 takes 2 3s to make it happen, doesn't it? And then there's 1 3 here and there's 1 3 here. I know that square root of 3 and square root of 3 over 3 are going to show up as tangents somewhere, and that just helps me remember where they go. Hopefully that helps you. We'll find out. Okay, in this section, I'm just showing what it's going to look like on your assignment. It's really the same things we've been doing. It's just giving it to us in a table form. So notice it's going to ask us a function. It's going to ask us, it could give us the degree, the radian, or the function value, and we just fill in the table what's left, okay? So first of all, on this first one, it says a cosine of 60 degrees. Well, go to 60 degrees, and cosine is x, right? So I would put in, like, the function value is 1/2. Now, what is 60 degrees as radians? That's pi over 3. Remember, we're working towards being able to do this by memory, but feel free to use your unit circle for this. Secant of pi over 4. Well, what is secant? That is hypotenuse over adjacent, right? Well, pi over 4 is 45 degrees, so I can put that in here. The secant is, we shouldn't say hypotenuse over adjacent in this term, should we? We should say r over x. So it's the reciprocal of x, which in this case is 1 over x. So at pi over 4, 1 over x, it's the reciprocal of square root of 2 over 2. So if I flip that over and I rationalize that, what am I going to get? Well, 2's will cancel, and I'll end up with just the square root of 2. All right, on cotangent, cotangent is going to be, instead of y over x for tangent, it's just going to be x over y. Well, let's see. If the cotangent is the square root of 3 over 3, that means the tangent had to be square root of 3, right? Those are reciprocals. So where is it square root of 3? Where pi over 3 is. So that's at pi over 3, using that little trick I just showed you, pi over 3, which is 60 degrees. All right, I hope that helped. We can do more of this in class if we need to. Move my circle. Now, this last section, using your calculator. Now, your calculator can't do everything, right? It's going to have your basic 3 trig functions, but it doesn't have all 6. So I'm going to have to flip over to my calculator in a moment. But set your calculator to desired mode. So that's something you're going to have to be aware of, okay? Your calculator has 2 modes. It has degree mode and it has radian mode. And you want to make sure you're using the correct one. Well, how do you know? Well, look at for a second at just your at the questions they gave us. Look, this has a degree symbol, so I'm going to use, I know I'm going to have to use degree mode on it, right? This one doesn't have a degree symbol, so I know I have to use radian mode. This one's in degree mode, and my last one is in radian mode. So what I would do is put my calculator in the correct mode. I'll show you how, and just work all the degree problems. Then go back, switch the mode, and make them radian problems, all right? So what do? Well, obviously in my calculator, I can hit the sign button and do 76.4, and it will generate for me the sign. Really easy peasy. Let me show you. So for mode, you want to look for the mode button right here, top row next to the second, just hit mode, and you'll notice that right underneath it says radian or degree. Now your calculator will default to radian mode, so I'm going to do my degree questions first. I need to go over there, highlight degree, hit enter, and now we're in degree mode. And just hit second in mode and it'll quit. Now I can do that question. Does it say sine of 76.4? Type it in, hit enter, and there's my answer. 0.972. We're rounding 3 decimals. 0.972. So easy enough, right? Okay, so let's jump over to the other degree question. Now, we're going to do secant. Now, the weird thing is there is no secant button on our calculator, right? It only has sine, cosine, and tangent. So what are we going to do to find our secant? Well, you have to remember that the secant is the 1 over cosine, isn't it? That is what secant is. So in order to make this happen, we're going to type in a 1 over and put it in cosine of 32.8 degrees. Now, you can write it like this as a fraction, or you can put it in like this. Put it in cosine of 32.8, close that parenthesis, and then I'll show you the button. It's right under the math button, but if you hit -1, it means the same as the reciprocal. Okay, it means the same as all that. So either way, you're going to get the right answer. So let me show you. Okay, so if I do it as a fraction first, alpha y equals, I can put 1 over the cosine of, 32.8, and I get this answer, right? The other way you can put it in is cosine 32.8, close the parenthesis, and then hit the x to the -1 button. It's right under math, okay? And if you hit enter, notice you get the same answer. Either way works, whatever keystrokes you want to use, but that you got to remember it's the reciprocal of cosine. And that gives us the answer of 1.8. If we're rounding to 3 decimals, that would be, 1.190, wouldn't it? 1.190. All right, so we're going to do the same thing now with the radians. So let's switch to radian mode. Switch to radian mode, so go to mode, change it to radians, hit enter, and I'm all good to go. So the first one on my paper says cotangent of 1.5, so that's the reciprocal of tangent, right? So again, I can do it this way, 1 over the tangent of 1.5, I can get that answer, or again, you can type it as tangent 1.5 to the -1 inverse power. There's my answer for that one. Now, if I jump on over and do the cosecant, I have to stop and think. Cosecant is what? The reciprocal of sine. So it's 1 over sine to the 1.2. There's that. Or again, I can hit the sine 1.2 to the negative 1 power. It's a little faster and get that answer. All right, let's write these down on our paper. Okay, so the radian on this one is 1.073. All right, so that's how you do radian degree mode, some of these reciprocal functions. A lot of stuff is covered in this assignment. So take your time, ask questions when you get to class. Good luck.